some word problems using this. Okay, so this inverse trig should have been pretty easy. You barely have to do any math with it, like any algebra. You just have to set up the problem. So now we're going to add word problems to it. Okay, I'm going to do the first one, and then I'm going to have you guys work on the second one. Okay, ready? Number 1, find to the nearest degree the angle that the sun rays make with the ground when a flagpole is 40 feet high and casts a 30 feet shadow. I want to know this angle right here. Okay, this is your opposite. This is your adjacent, so you're going to use, we look at SOHCAHTOA, we're going to use tan. Inverse tan, opposite, over adjacent, and then we just stick that in our calculator, and we're going to round to the nearest degree. So we're going to get 53 degrees. Okay, for this next one, any questions on that?
No.
How I figured out where 30 and 40 went?
No.
How I labeled it opposite and adjacent? How I picked tangent? We're good. Okay. Number 2, I want you to draw this picture. Okay, let's draw it on our own. See if we get the same one. Ready? The top of a 40-foot ladder, which is leaning against a wall, reaches the wall at a point 36 feet from the ground. Find to the nearest degree the angle that the ladder makes with the wall. Let me read it one more time. A 40-foot ladder leans against a wall 36 feet from the ground. Find to the nearest degree the angle that the ladder makes with the wall. If you feel confident about putting your 40, 36, and where your angle goes in your picture, label it opposite, adjacent, and hypotenuse. But everybody should be able to draw a right triangle, right? We know that's there. Then figure out which side is 40, which side is 36, which angle it's talking about. Reread the problem if you need to. Where's your angle? So I have a lot of people making this mistake when I walk around. Find the angle that the ladder makes with the wall. Remember, which one's the ladder, which one's the wall, where would that angle be? Okay. So we've all got a right triangle, right? Everybody can do this. Okay, we know the ladder's leaning against the wall, right? So we're pretty sure the ladder's here. I saw most people have that correct. Most people had that it was 36 feet off the ground. We know that this is 90 degrees because the ground and the wall make a 90-degree angle, right? Where's my angle, though?
Up there.
Up top, because it says the ladder and the wall. It doesn't say the ladder and the ground. It says the ladder and the wall. Everybody okay with that? So 36 is my opposite, adjacent, or hypotenuse? Adjacent. 40 is my opposite or hypotenuse? So which one uses H and A? Cosine. Good. So we're going to do the inverse cosine, adjacent over hypotenuse, and what do I get, guys? 26 degrees when we round to the nearest degree. Okay. The next one I'm probably going to draw for you because I want to show you what an isosceles triangle looks like, in case some of you are confused. An isosceles triangle has side lengths 5, 5, and 6. Find the measure to the nearest degree of each angle. Hint, draw the altitude. Okay, so let's draw a triangle. We're not drawing a right triangle. We're drawing an isosceles. 5, 5, and 6. You guys see that? Okay, we're going to draw the altitude, which is from this top corner down. I've just made it into a right triangle. But this bottom's not 6 now. What is it? Good. But I want to find each angle. I want to find this angle down here, x, this angle up here, y. Okay? Let's find x first. If we're looking at x, what is 3? And what is 5? Good. So we're going to use which trig function?
Cosine.
So the inverse cosine of 3 over 5 gives me approximately 53 degrees. That's x. That's these 2 degrees right here. Okay? Now I need to find y, which means 3 is no longer my adjacent. It's my what? Opposite. Good. Is 5 still my hypotenuse? Yeah. So if I have opposite and hypotenuse, which trig function do I use? Sine. So the inverse sine function of 3 over 5 gives me 37 degrees. But this is only 37 degrees. I want that whole angle. I want this angle. What am I going to do to it? Times it by 2, and I get 74 degrees. So this whole angle is 74 degrees. Yes, Nathan.
The inside angles of all triangles, isn't it like 180?
Yes.
So couldn't you have taken the 2 angles and then add
Yes.
those together?
You could have taken 180 minus 53 minus 53. Questions about this? All right, go ahead and do the back. Remember, you're probably going to finish the back before the end of the hour. I will then suggest that you come over here and pick up it sticking straight up and down in the geometry box. I don't want to lay it out because I don't want you guys to think it's due tomorrow. It's not due till Tuesday. And you can start working on this. If you don't want homework over your 3-day weekend, start working on it today and do it tomorrow in class, right? So then you don't have to do anything over the 3-day weekend.
Wait.
Alyssa, look at
Yep.
that.